Hello geographers and welcome to the AQA GCSE Geography podcast. A huge shout out to my awesome class 11D2, God I love you, and to anybody listening out there on the web. I make resources to go along with this podcast and today's session is all about rivers. This will be in your paper 1 and will be one of the final sections that you will complete. For my class it will be because we'll do coasts question 4 followed by rivers question 5. So today the supporting materials is a revision booklet and it's a little bit more of a fill-in as you go. So you may need to pause this podcast a few times, listen again back to some of the tips, some of the descriptions I give, and also of course you can use sites like BBC Bitesize for further help and support. The first thing I want you to do is have a little look at page 3 because it begins with a drainage basin. You've got a task there to define some of the key terms on the drainage basin, like the river source where it all begins and the river mouth where the river actually meets the sea. But then you have this thing called a watershed, or it's sometimes also called a drainage basin. And that's quite difficult and it's a question that always comes up. So my tip here is to think of both as quite literally the area that is drained by any stream connected to that river. So any place in that drainage basin where a bit of rain falls will end up in that river. And that's a very important key term. You need to think about, though, how actually the characteristics, that's the posh word for basically saying features, like the characteristics of my face is, my blue eyes. No, correction, that's brown eyes if you know me. Okay, I'm waffling. But the characteristics of a drainage basin and how it can actually flood. So if you've got a drainage basin and the rock type is actually very permeable, the water's actually going to sink through. It's actually going to go through and infiltrate, we call it. You're less likely to have a drainage basin that's going to flood. That water can infiltrate and percolate through to the rocks down to the groundwater below. Maybe you've got a drainage basin though which actually has got a lot of building on, a lot of urbanisation. Actually these are impermeable surfaces. Think about the road, think about your street, think about your house with those roof tiles. Actually this is really bad for a drainage basin because that water is actually going to run off and increase the likelihood of flooding. So take a moment now to complete page 3 and do that task about how the characteristics of having impermeable surfaces and rock types versus the lovely permeable ones which allow the rainwater to soak through, how that can affect the flood risk. Okay, we're back then and we're moving on to page 6. Here comes some more terminology all about erosion and how the processes of erosion affects the rivers and their valleys. The first part there, number 6 on the page, we've got the different types of erosion. Now my class, I've taught you it as a little word called cash. So we have got the corrosion or abrasion followed by the attrition. Then we've got the solution, or sometimes called the corrosion, where things are wearing away, and we've got the hydraulic action. We went through this in the podcast last week for coastal erosion, and if you need to, go back and listen to it now. But we've got different types of action happening. We've got the actual power, what we call the sandpaper effect of that corrosion or abrasion, where it's almost like the sides of the river bank and the river bed are being eroded away by sandpaper. Then we've got to think about the factors that affect this erosion, affect things like this sandpaper action. So of course, if the river's very full, if it's got a lot of energy, it's going to have more power to scour away. If the gradient is steep, if it's rushing down more quickly, it's going to scour that bed a lot more quickly as well. Then you've got the bed load. What is it actually carrying? Has it been a time of flood and so there are lots of rocks, lots of sediment and material being carried? That's going to increase the rates of erosion. Or is it more a period of drought like we had in the heat wave of 2018 where our rivers were drying up and so it's not going to have that erosive power? And then finally on this page, we've actually got how the rivers transport material. Now, there's no clever word to remember this like cash, because it involves a T and 3 S's. So I'm going to say st. We've got suspension. So we've literally got tiny particles, like think of sand, carried along in the river. We've got solution, we've got my cup of tea effect. If I've got sugar in my hot cup of tea, I know it's there when I taste it, but we're not going to be able to see that under the microscope, not with the human eye. We've got my favourite one, saltation. So we have at Wilden here ping pong tables. So think of the ping pong ball for table tennis. We've got our pebbles which are bounced along just like a ping pong ball. And then we've got our tea, my favourite one, the traction. I always think of tractor wheels and how then these huge boulders are rolled along the riverbed. So take a moment again to pause, write down some definitions, look back at your coastal work when we did this last week with our podcast, and make sure you can define all those terms now before we move on to page 5. Okay, I'm back. Thanks for listening, 11D, and hopefully your parents. Big shout out to you guys. Okay, next then we're on to page 6 and how rivers change from the upper, middle and lower course. Now this is called the long profile of a river. It confuses students every time and I'm really sorry about it. But you've just got to think it's a story, like a long story of the river when it's teeny tiny, up in the mountains, there's lovely little streams until then it actually meets the river mouth. So for my class, think about as you head into Southampton, you might go the way over maybe the Itchen Bridge and you've got to pay that toll, or you might go the way actually the other way past St Mary's Stadium. But this is where the Itchen River is getting wider. And so, of course, it's a lot flatter. So we've got to think about this story. Now, the gradient is going to go from being very steep to very flat and gentle. The discharge is going to go from being quite small to actually being very high. Sorry, I'm having a little giggle at the word discharge. If you're in my class, you understand I am a real child. I know, Megan, I know. Then we move on to velocity. So this is the speed. So actually at the start, the speed isn't always that fast because it is only a tiny stream. It will be moving downhill, but it's going to be quite narrow. Actually, the speed can be quite fast in the lower course. That area where we are at, St Mary's Stadium or the Itchen Bridge for my class, actually it can be flowing quite speedily because it's so big there. There's so much discharge. Now the channel shape is going to change from very V, very steep, to really flat and a gentle U. And the valley is going to change just the same from being very steep in the upper course to this very gentle U shape. And of course that's why the flood risk can be so bad in the middle and lower course, because our valley sides are quite flat. So take a moment to get the rest of that table in. If you need to, have a little look at BBC Bitesize. They've got links to a brilliant video here. And my class, with this document on our Google Classroom, I've popped the Vanessa video, which you'll remember, with her ponds and puddles and dribbles and trickles, as she follows the River Severn from its source to its mouth. So that would be great to help you with there. Okay, we're moving on now to page number 6, and I'm not going to go through these too much because this is now a chance for you to revise how waterfalls actually form. So you've got a brilliant diagram there I'd like you to annotate and really make sure you remember those keywords: the overhang, the plunge pool and the gorge. So make sure you annotate those now. And then moving on to page 7, we've got actually the good old-fashioned topic of the meanders and the oxbow lakes. Maybe now make a cup of tea, go chat to your mum and dad about it, because I can guarantee if they did geography at school they will remember, oh yeah, meanders and oxbow lakes. So take a moment to do that now. I will say I have got a prediction about floodplains. I really think floodplain formation is going to happen, and that's where a river will naturally flood as it is meant to. It is meant to naturally flood. We ignore this and build on it and get all upset. No idea why, but we do. It's meant to naturally flood, and when it floods, these particles it's been carrying through that suspension, through that siltation, will of course be deposited either side of the river, and that builds up these natural little mini earth banks, which are beautiful, which are brilliant, but I do have a feeling they're going to come up, so make sure you have a little look back at those as well. Okay, as we move towards the end of this booklet, I'm going to talk about hydrographs. I'm going to be honest and say they still confuse me as a geography teacher. So I have so much empathy if you're still trying to understand them. Essentially though, look at page 8 now. And the top right hand diagram. What you're looking is from the little bar chart which tells you how bad the rain was falling, to that green, so it's in green, it's in colour here, that green rising limb and recession limb, which is basically our discharge. That line graph is how much water's in the river. Now this one is what I call really flashy. It's really steep and very high. That lag time is actually going to be quite short. Now this is all you need to remember for these. A short lag time is going to tell you that river is going to flood. If instead, if you actually look at the one below, the diagram below, and you see the before urbanisation blue line, a much flatter line is actually going to tell you it's not going to flood. So you'll get questions actually looking at the shapes of them. If it's very steep, that rising limb, you know it's more likely to flood. If it's a lot more gentle, the river can cope with it. And quite often it's just down to urbanisation. Just like with Hedge End and the Borley Park development, we're building more roads, we're building these housing estates, and instead our rainwater is going to run straight off down into our drains and it's going to make its way back to the river. Okay, on to the last kind of bits I want to cover now with the causes of flooding and Boscastle case study. Boscastle's back in 2004, so I know this is getting on to just before you were born, but it's a cracking example of how a flash flood, a great deal of rain, a whole month's worth in 2 hours, inundated this poor village and sadly devastated the buildings. Some were destroyed, 75 cars were washed away, but thankfully there was no risk to human life. So this study, I will have the little video clip that we watched on with the resources for my class here. If you're listening out there in the great wide world web there, you might not have studied Boscastle, so think about the flood that your teacher taught you. Look back at your notes, and I want you to complete these 2 pages here about the causes and the social, economic and the environmental effects there. The social effects, the community was devastated for a while. They lost obviously their businesses, they had to wait for insurance money to rebuild. This teeny tiny little village, so for my class, think the size of Botley High Street. That's all it was, Botley High Street. That's a lot of money for something which was just the size of Botley High Street. It devastated them. But the great news is we took action, and we can do this. We can spend some money and we can actually try to reduce the risks of floods in the future. So the best thing they did was to dredge the channel, widen it and deepen it. And this increases the amount of discharge. When there was another flood event 3 years later in 2007, the same thing didn't happen. The people and their property was safe. The other thing we did was we braided the channel upstream. So instead of all the rainwater crashing into the River Jordan and Valency, we braided the channel so it took some time to actually get into the river. They made an overflow channel, so they made a runoff drain, which again was a massive help. We actually encouraged some tree planting and afforestation for the trees to intercept the rainwater. So look at on page 10 that diagram there. There were actually about 9 things that the Environment Agency did at a cost of 4 million. But when you consider the clean-up insurance cost was 60 million, what an absolute bargain. So have a little look there now, and this is where we're going to end. My class, listening to this podcast is part of your February revision of the home, as I call it, and I will be doing a little mini test on this. But also go to our Google Classroom where I've popped these further links. Once again, thank you so much for listening, my class, and hopefully my class's parents. And if you are listening out there on the World Wide Web, you can find these resources from Spotify. Back next time for hopefully more helpful further tips. Thanks so much for listening. Bye for now. Hello, geographers.